Hello everyone, welcome to the channel. In this video, we will see how Newton's second law is used to solve the pulley problem. The problem states that masses A 5 kg, B 10 kg, C 20 kg are connected as shown in the figure by an inextensible cord passing over massless and frictionless pulley. The coefficient of friction for masses A and B with the ground is 0.2. If the system is released from the rest, find the acceleration of the blocks and the tension in the cord. Okay, so first we'll write the given data. So mass A 5 kg, mass B 10 kg, mass C 20 kg. Okay, so they have given the coefficient of friction for masses A and B as well. That is mu A equal to mu B equal to 0.2. Okay, so that means they are resting on the horizontal surface. Okay, so for both the masses, the coefficient of friction is same. So what are we supposed to find? So to find the acceleration. Okay, first we have to find the acceleration A and acceleration of the blocks. Second one is acceleration of the blocks. That means we have three blocks, that is A suffix A suffix B and A suffix C. Then the tension in the cord. Okay, tension in the cords. So this is equal to question mark. Okay, so solution. So first of all, we'll try to understand the problem here. If you see, we have two blocks. Okay, mass A and mass B, and we have two blocks and we have two strings as well. So this mass B is connected to C separately and mass is connected to this mass C separately. But if you see here, we have two different blocks and two different strings. So that means the tension. Okay, so if the tension here will be different because we have the masses of the blocks are different. So that is why we have a tension will be different. So by this block we have a tension like this. Okay, and again we have a tension over here as well in this direction. So T2. Okay, so here we'll have a tension, here we'll have a tension of different. So this will be T2. So this is B blocks. I'm taking this as a T2. So for A block, I'll take it as a T1, upward, downward, and T1. Okay, so why we have a different tension? Because the masses of the blocks are different. That is the reason we have a tension will be different. Okay, now the second thing is, so if the block C moves in downward direction, if the block C is moves in downward direction, the acceleration will be same for all the blocks. Why? Because B is connected to C and A is also connected to C. That means the acceleration will be same. Acceleration will be same. Will be same for all the blocks. Okay. Since all the bodies are connected. Okay. So we have to find the acceleration. All the three bodies. Okay. So all the three bodies or three blocks are connected to each other. Three blocks are connected. So acceleration of all the blocks will be same. Okay, so will be same. So we know why also. Okay, that means A suffix A will be equal to A suffix B will be equal to A suffix C will be equal to A. So we have to find only one acceleration, and if you're finding that acceleration will be same for all the blocks as well. Okay, now how are we going to find out? So first of all, we are going to consider the FBD for different blocks as well. Consider FBD for block A. Okay, for block A. So we'll look at the diagram first. If you see, the block A is resting on the horizontal surface and it has a tension in the left to right direction. Okay, so if the blocks B move in downward direction, the block A direction will be left to right. Okay, so we'll draw the FBD. So this is the direction of the tension and the direction of the block in this direction, A, positive. Okay, so we'll have a normal, it's resting on the horizontal surface, we have a normal, and we'll have a weight as well. Okay, weight of the block, W. So they have given in terms of kg, so 5 into 9.81. Okay, and we'll have a frictional force in this direction opposite towards the direction of the block, that is mu A into N. Okay, and other forces, yeah, these are the forces will be acting over here. So we'll frame the equation. So we know that N will be directly equal to the weight of the block. Okay, so here there is no any component. So summation of f of x by Newton's second law, m into ax. Okay, this is a block A, so I'm taking this as a suffix a. So summation of f of x, all the horizontal forces. So here we'll have a tension because the tension will be positive in the same direction. The tension will be positive, minus mu dot n. So mu is 0.2. So n equal to 5 into 9.81. Okay, so this is the n value. This will be equal to mass of the block is 5 kg into A, because A suffix is equal to A. So this is your okay, so here tension is T1. Okay, so forgot to say, because here we have tension is T1, so we have to mention that tension is T1. So this T1 minus this thing, so I'm taking this T1 equal to 5 plus, if I multiply that value, 0.2 into 5 into 9.81. So okay, it will give me the same value, 9.81. So plus 9.81. So this is the first equation from the block A. Now consider FBD for block B. Okay, so here also we can see block B also is resting on the horizontal surface, but here the tension is T2. Okay, so we'll draw the diagram. Block B, so the tension will be in this direction, T2, and the direction of the block is also from right to left. Direction right to left. So okay, this is the direction. So direction is this way. So here we'll have the frictional force mu B dot N. We'll have the normal force, normal reaction. We'll have the weight is also acting downward. The weight of the block B is 10 kg. It is 10 into 9.81. Okay, we will get as 98.1. So again, by Newton's second law, summation of f of x equal to m into a b. Okay, so f of x again T2 minus of mu b is 0.2, normal equal to, normal is 98.1 because 10 into 9.81. So this will be equal to mass of the block B is 10 kg into A. Okay, so I'm going to take this in terms of a T2 equation. So 0.2 into 9.81, it is 9.81, it is 1.962. So this will be 10a plus 9.62. Okay, so 0.2 into 98.1, 19.62. So this is your second equation from block B. Now consider block C FBD. Okay, yeah. So block C is different. See, so block C is again, it's not resting on any surface, it's just hanging. So we'll have one weight of the block and we have two different tension. from A and from B, that is T1 and T2. So block C, the weight of the body will be acting downward, it is just hanging. So here we'll have a tension, that is T1 from A block and T2 from B block. Okay, so the weight is 20 kg. So this will be 20 into 9.81 Newton. Okay, so again we are going to use the Newton's second law. Summation of f of x will be equal to m into AC. Okay, so f of x, so here there is no horizontal forces, so we will be using only the vertical forces. Okay, so we will use the equation f of y. So summation of f of y will be equal to m into ay. Okay, so here in terms of ay I can take a. So f of y, the equations are direction is downward, direction is downward, right? Direction is downward. Downward we have only weight, that is 20 into 9.81 minus T1 minus T2 equal to 20 kg into A. Okay, right? So what we can do is this is your third equation, or else we can keep it the same equation. We can substituting one and second equation in, okay, this will take this third equation in third equation. Okay, in third equation. So why we are substituting? Because we know that there is a value of a T1 equation, we have a T2 equation. Okay, so T1 equal to 5a plus 9.81. So 20 into 9.81 minus of 5a minus 9.81 and minus of T2. So what is the equation of T2? It is 10a plus 19.62. So that means minus 10a minus 19.62. So this will be equal to 20a. Okay, so if you put it this in the calculator, solve the equation for x. Okay, so we will get a will be equal to 4.76 meter per second square. Okay, so this will be the acceleration of the all the three blocks. Okay, so we found the acceleration. Now we have to find the tensions. So tension, again substitute a in first equation, you will get T1. So T1 equal to 5a plus 9.81. So this will be equal T1 equal to 5 into 4.76 plus 9.81. Okay, so T1 will be equal to, let me calculate it, 5 into 4.76 plus 9.81. So it gives me 33.61 Newton. So this is for tension 1, and similarly substitute a in second equation to get the T2. So T2 will be equal to, so T2 equation is 10a plus 19.62. This will be equal to 10 into 4.76 plus 19.62. So T2 will be equal to, let me calculate, 10 into 4.76 plus 19.62. It gives me 67.22 Newton. Okay, so I hope you understood this problem. So if you have any doubt, you can put it in the comment section. Thank you for watching.